Hello everyone. I am Snehavalli in pursuing 4th year CSE at Sethu Institute of Technology. My topic is Big Data Analytics. Synopsis: Hadoop MapReduce Architecture, HDFS. HDFS demands file block size, replication in HDFS, Hadoop cluster, Hadoop installation. Hadoop. Apache Hadoop is an open source framework that it is used to efficiently store and process large data sets ranging in size from gigabytes to petabytes of data. Instead of using one large computer to store and process the data, Hadoop allows clustering multiple computers to analyze massive datasets in parallel more quickly. Architecture. MapReduce. MapReduce is a programming paradigm that enables massive scalability across hundreds or thousands of servers in a Hadoop cluster. As the processing component, MapReduce is the heart of Apache Hadoop. The term MapReduce refers to two separate and distinct tasks that Hadoop programs perform. The reduced job takes the output from a map as input and combines those data tuples and into a smaller set of tuples. Architecture. Input splits, mapping, shuffling, sorting, reducing. Architecture. Client. The MapReduce client is the one who brings the job to the MapReduce for processing. There can be multiple clients available that continuously send jobs for processing to the Hadoop MapReduce manager. Job. The MapReduce job is the actual work that the client wanted to do, which is comprised of so many smaller tasks that the client wants to process or execute. Hadoop MapReduce master. It divides the particular job into subsequent job parts or job parts. The tasks are sub-jobs that are obtained after dividing the main job. The result of all the job parts combined to produce the final output. Input data. The data set that is fed to the MapReduce for processing. Output data. The final result is obtained after the processing. Architecture. Input, input splits, mapping, shuffling, reducer, and final output. HDFS. HDFS is a distributed file system that handles large data sets running on commodity hardware. It is used to scale a single Apache Hadoop cluster to hundreds of nodes. HDFS is one of the major components of Apache Hadoop, the others being MapReduce and Yarn. HDFS should not be confused with other replaced by Apache Couchbase, which is a column-oriented non-relation database management system that sits on top of HDFS and can better support real-time data needs with its in-memory processing engine. HDFS is intended more for batch processing versus interacting use, so the emphasis in the design is for high data throughput rates which accommodate streaming access to dataset. HDFS accommodates applications that have datasets typically gigabytes to terabytes in size. HDFS provides high aggregate data bandwidth and can scale to hundreds of nodes in a single. Daemons. The daemons are the process that run in the background of the system. The components of Hadoop known as daemons include name node, secondary name node, data node, job tracker, and task tracker. Each daemon contains its operations, autonomously within its JVM. Hadoop daemons are a group of Hadoop processes that work together. Hadoop is a platform built on Java. Hence, each of these processes is a Java process. Daemons. The components that make up Apache Hadoop 2 are follows: name node, resource manager, data node, name node, data node, node manager, secondary name node. Name node. The name node daemon is a master daemon and is responsible for storing all the location informations of the file present in HDFS. The actual data is never stored on a name node. In other words, it holds the metadata of the files in HDFS. Resource Manager. A resource manager is a process that maps resource and resource class abstractions into actual calls and commands for one or more specific types of resources. A resource manager runs as a stand-alone daemon and contains definitions of all resource classes that the resource manager supports. Data node. The data node daemon acts as a slave node and is responsible for storing the actual files in HDFS. The files are split as data blocks across the cluster. The blocks are typically 64 MB to 128 MB size blocks. The block size is a configurable parameter. Name node data node is the responsibility of the name node data node maintain a list of the files and their corresponding locations on the cluster. Whenever a client needs to access a file, the name node data node provides the locations of the file to client and the client then access the file directly from the data node daemon. Node Manager. The node manager works on the slave system that manages the memory resource within the node and memory disk. Each slave node in a Hadoop cluster has a single node manager. Daemon running in it also sends this monitoring information to the resource manager. Secondary name node. Secondary name node is used for taking the hourly backup of the data. In case the Hadoop cluster fails or crashes, the secondary name node will take the hourly backup or checkpoints of the data and store this data into a file named FS image. This file then gets transferred to a new system. Application in HDFS. Each block has multiple copies in HDFS. A big file gets split into multiple blocks and each block gets stored to a 3 different data nodes. The default replication factor is 3. Please note that no two copies will be on the same data node. Hadoop clusters are composed of a network of master and worker nodes that orchestrate and execute the various jobs across the Hadoop distributed file system. The master nodes typically utilize higher quality hardware and include a name node, secondary name node, and job tracker with each running on a separate machine. The workers consist of virtual machines running both data node and task tracker services on community hardware and do the actual working of storing and processing the jobs as directed by the master nodes. Hadoop installation. Step 1. Click here to download the Java 8 package. Save this file in your home directory. Step 2. Extract the Java tar file command. Step 3. Download the Hadoop 2.7.3 package. Download Hadoop package. Install Hadoop Edreka. Step 4. Extract the Hadoop tar file command. Hadoop installation. Step 5. Add the Hadoop and Java paths in the pass file. Step 6. Edit the Hadoop configurations files. Step 7. Open the core site XML and edit the property mentioned below inside configuration. Step 8. Edit HDFS site XML and edit the property mentioned inside configuration. Step 9. Edit the morphed site XML file and edited the property mentioned below inside configuration. Step 10. Edit an site XML and edit the property mentioned below inside configuration tag. Step 11. Edit Hadoop env.sh and add the Java path as mentioned below. Step 12. Go to Hadoop home directory and format the name node. Step 13. Once the name node is formatted, go to Hadoop 2.7.3 or spin directory and start all the demos. Step 14. To check that all the Hadoop services are up and running, run the below command. Step 15. Now open the Mozilla browser and go to localhost. Advantages of Hadoop. Hadoop is open source and uses cost effective commodity hardware which provides a cost effective model unlike traditional relational databases that require expensive hardware and high end processors to deal with big data. The problem with traditional relational databases is that storing the massive volume of data is not cost effective, so the company started to remove the raw data. Scalability. Hadoop is a highly scalable model. A large amount of data is divided into multiple inexpensive machines in a cluster which is processed parallelly. The number of these machines or nodes can be increased or decreased as per the enterprise's requirements. In traditional RDBMS, the systems cannot be scaled to approach the large amount of data. Flexibility. Hadoop is designed in such a way that it can deal with any kind of dataset like structured, semi-structured, unstructured very efficiently. This means it can easily process and kind of data independent of its structure, which makes it highly flexible, which is very much useful for enterprises as they can process large data sets easily. So the businesses can use Hadoop to analyze valuable insights of data from sources like social media, email, etc. With this flexibility, Hadoop can be used with log processing, data warehousing, fraud detection, etc. Speed. Hadoop uses a distributed file system to manage its storage. Example, HDFS. In DFS is a large size file is broken into small size file blocks then distributed among the nodes available in a Hadoop cluster. As the massive number of file blocks are processed parallelly, which makes Hadoop faster, because of which it provides a high level performance as compared to the traditional database management system. When you are dealing with a large amount of unstructured data, speed is an important factor. With Hadoop, you can easily access TBs of data in just a few minutes. Fault tolerance. Hadoop uses commodity hardware which can be crashed at any moment. In Hadoop, data is replicated on various data nodes in a Hadoop cluster, which ensures the availability of data if somehow any of your systems got crashed. You can read all of the data from a single machine. If this machine faces a technical issue, data can also be read from other nodes in a Hadoop cluster because the data is copied or replicated by default. Hadoop makes three copies of each file block and stored it into different nodes. Disadvantages of Hadoop. Problem with small files. Hadoop can efficiently perform over a small number of files of large size. Hadoop stores the file in the form of file blocks, which are from 128 MB in size to 256 MB. Hadoop fails when it needs to access the small size file in a large amount. This so many small files surcharge the name node and make it difficult to work. Vulnerability. Hadoop is a framework that is written in Java, and Java is one of the most commonly used programming languages, which makes it more insecure as it can be easily exploited by any of the cyber criminals. Low performance in small data surrounding. Hadoop is mainly designed for dealing with large data sets, so it can be efficiently utilized for the organizations that are generating a massive volume of data. Its efficiency decreases while performing in small data surroundings. Lack of security. Data is everything for an organization. By default, the security feature in Hadoop is made unavailable. So, the data driver needs to be careful with this security phase and should take appropriate action on it. Hadoop uses Kerberos for security feature which is not easy to manage. Storage and network encryption are missing the Kerberos, which makes us more concerned about it. Higher processing. Read or write operation in Hadoop is immoderate since we are dealing with large size data that it is TB or PB. In Hadoop, the data read or write done from the disk, which makes it difficult to perform in memory calculation and lead to processing overhead or higher processing. Support only batch processing. The batch process is nothing but the process that are running in the background and does not have any kind of instruction with the user. The engines used for this process inside the Hadoop core is not that much efficient. Producing the output with low latency is not possible with it. Thank you.